so let's start off our journey with the center of mass. All right, so we'll do two things as usual: understand the definition and how to calculate it. Okay, so let's start with the definition. So the object's center of mass is, and I'll say that first, is when you apply a force to it, it will go in a straight line and it will not rotate. Okay, so we'll put that in words. So center of mass is the position of the object of interest. So the position of the object where it will move in a straight line without rotating if a force is applied on it. Okay, so it's annoying to write it out, but the concept is very simple, right? So you have an object. If this is the center of mass, if you're able to push, ideally you'll be able to push from the center, but that's a bit hard unless you tie a string from here and sort of drill a hole and sort of pull it and yank it that way. Yeah, that will be fine. But even if you push along sort of here, even though if it's irregular, it will move in a straight line. Yeah, that's not really the same object. Assume I can draw this like copy and paste on a computer. It will move in a straight line without rotating. Now, if you push I'm not drawing a free body diagram, I'm drawing a physical diagram. Okay, so if I push it at this point, it will start rotate, it will move forward and it will rotate as well. Okay, so the center of mass is the position, right, in the object, or of the position of the object where it will move in a straight line without rotating if a force is applied on it. Okay, all right, so next question is, so that's very simple, but how do we calculate it? Okay, I can give you the equation definition of this, but that essentially tells you how to calculate it, and it's a little bit complicated because I can write it right now. It's xcm. If it's one dimension, it's xcm sum of mi xi over sum of mi, like that. That will mean nothing to you. So let me motivate this bit by bit, and also if it's 3 dimension, but you know what, you can drop that down first, and then we'll try to disentangle that. If it's in 3 dimension or in 2 or 3 dimension, it's sum of mi ri over sum of mi. Okay. Basically just change the x into our vector. So that's the position vector. So position vector of each point I, and this is the mass of each point I. Okay, so yeah, and that's the position of the center of mass. Okay, that's just the one dimension of it. So you can rewrite this as position of center of mass, but instead of position vector, just say position of each point I. Okay, all right. So what does that mean? That looks very complicated. In fact, if it's a continuous distribution, you need to replace this with an integral as well. Okay, I'll put that in for completeness as well. I'll put the 1D version of it. So if it's a continuous mass distribution, because it's in your textbook, distribution, this is actually the most general version. It's defined as integrate x dm and integrate dm, like that. Okay, so you change the you change this into you change the summation, the discrete summation, into an integral, like this. Okay, yeah. So lots to unpack, right? So let's start with very simple. Let's start with point masses. Okay, and to understand how to calculate. Now let's start with point masses. Notice that it's plural now, because if I just have a point mass here, where's the center of mass? It's here. Okay, so this is, all right, case number 1, right? So one point mass, that's the center of mass. It's over here. Now notice center of mass. What is it? What quantity is it? It's ultimately a position, right? It's in 1D, it's x. In 3D, it's r. It's a vector. So how do you describe position? Remember, to describe directions, you need 3 pieces of information. To describe position, you also need, in addition, you also need a origin. All right. So I can't just say, like I said, the quintessential test of whether you're describing something scientifically is, can you communicate that over the phone? Realistically is, can you communicate that on paper? But just so it's more visual, can you write down or can you communicate over the phone and tell people exactly where you're talking about? So you need to decide on an origin first. So if, let's say in 3D, okay, what you need is, let's say you need an x, so you need, right, you need an axis and you need an origin. So this is my origin and this is my axis. Now you can talk about position. So where's the center of mass? Now you can talk about this vector. So this is RCM, okay? And you can talk about how many units this way, how many units that way, okay, in its components like that. Okay, so RCM can be XCM units in the X direction and YCM units in the Y direction, like that, okay? But if things are just in one dimension, you just need the origin. Let's say this is X equals to 0, this is positive X, then XCM is just here, okay? So 1D, it's just one vector like this and you're done. Okay, sorry, not 1D, 1-point mass. Okay, how about 2-point masses? Okay, so now let's start with one dimension. Okay, and let's start with equal point mass. Okay, so equal masses. And so let's call this 2A. Again, you need an origin and you need an axis. Otherwise, I can't talk about position. Remember, if we calculate center of mass, we want to calculate, let me try to draw this in a straight line. We want to calculate the position. So in order to describe position properly, I need an origin and and a grid, right? And an axis like that. Okay, 2 things, right? Axis and origin. Now let's say the first one is here at x equals to, so I have mass at x equals to 3 and mass m at x equals 5. Where is the center of mass? Okay. Can you guess? Well, it should be at x equals to 4. How do you get that? All right. So the answer is XCM is 4. But how did you get that? You would guess is probably, well, I'll take 3 plus 5 divided by 2. I just took the average, right? This is where the center of mass is. Okay, you're correct. All right, but now let's figure out how I got this, because I can have something more complicated if this is 0 and then the first mass is here at -1, and then the other mass is over here. So what if I have 3 mass, for example, right? So I have 3 mass of equal mass, and this is at 2 and 3, right? Now it's not so obvious. So now let's see if we can take the simple case and sort of upgrade and ultimately get to the proper one that's in your textbook, right? That you get. We'll very rarely use the integral version, but the one with the discrete sum that I just erased, that one you will need to know how to use it. So let's see if we can build our way up to there and see if it makes sense all the way, right? At every step of the way. Okay, so this is correct, yeah. But now I want to generalize a rule from it. And I think the rule over here, right? So it's 4, it's correct. Yeah, I don't like to write things horizontally. It's better to do it this way. But yeah, so where did 3 come from? How if you're trying to teach a kid how to figure out the answer, you know the answer is 4. How do you figure it out? Well, you say it's the position of the first mass plus the position of the second mass divided by 2. Okay, so the kid will ask you, oh, where's 3? How did you invent the number 3 in this equation, right? it's too fancy, it's too overkill to call this a equation, but it is what it is, right? So, well, it's the position, so x of mass 1, right? This is the first mass, plus x of the second mass divided by 2. And before you copy 2, now imagine teaching this to your 5-year-old nephew, and he would start asking, well, where did you come up with the number 2? You say, well, there's 2 masses, right? So there is 2 masses, so that's why here you should put the number of masses, all right? So where x1 is the position, so notice the importance of whenever you write symbols, you need to define what they mean, the position of mass 1, position of mass 2, and n is the total number of masses. Okay, good. All right, and just for completeness, XCM is the position of the center of mass. Okay, or you can just say center of mass, since center of mass is the position. All right, good. So now I can generalize it to here. So let's call this 2B, where I have, you can write it down, 3-point mass of equal masses. So XCM, now I can say, okay, so it's X1, the first point mass, plus X2 plus X3 over the number of masses, all right? So can I write this in a even more general way? And yes, so this is identical to sum of Xi over sum of I. Okay, now it looks scary, but let's look at it bit by bit, and hopefully we'll demystify this, right? So the first line you see, sum of Xi, what does that mean? So this means, right, summing I from, this is actually a lazy way to write I equals 1 to n, but you need to define what n is. So n is the number of mass. Yeah, so let's actually do that. N, I equals 1 to n, right? So that we're not that lazy, right? So n is the total number of point masses. Okay. So let's unpack this and see if that makes sense. So first you write x1 plus x2 plus x3. Okay, so the top makes sense, right? Because in my case, n is 3 because I have 3-point masses. And over here, I need to sum first. I need to sum when I equals to 1. All right, so when I equals to 1, sorry, that's not I, that's just 1. Sorry about that. So when I equals to 1, you will sum, all right, 1. All right, so this is, notice this is the term I equals to 1, this is the term I equals to 2, this is the term I equals to 3, right? So I equals to, so that's the top. On the bottom, again, we should have 3 terms. The first term is when I equals to 1, second term is I equals to 2, third term is I equals to 3. Okay, so here, when I equals to 1, what's the term? Term is 1. This is independent of I. So this, when I equals to 2, this is just 1. When I equals to 3, it's also 1. So on the bottom, it reproduces 3, exactly what we want, like that, right? So, and so normally, yeah, so here so basically this is 1 plus 1 plus 1, adding n times, okay? Hopefully that makes sense. If you want, you can write this down. It's almost trivial, but sum of 1 equals to n. That is a mathematical truth, a mathematical identity. Yeah, so in this case, you'll go, all right, minus 1, x equals the position of, what's x1? It's the position of point mass 1. So the position that is x equals to minus 1 plus x equals to 2 plus x equals to 3. All right, so this is 4 over 3, right? 1 plus 1 plus 1, so I have 4 over 3. And so that's roughly 1.3. So somewhere over here. Okay, so this is XCM, right? So that kind of makes sense, right? It's heavier over here, so the center of mass is, it's not halfway point between -1 and 3. Otherwise, that would be that would be x equals to 1, but right, because 2 units this way, x equals to 1, 2 units this way, x equals to 1, but it's shifted just a little bit, right? Because there's more mass tilted towards this side than just the midway point. So it's not just a midway point between things, but you take an average, okay? Now, what if the masses are not equal?